Alright, in this problem we have a moon orbiting the planet Donda. Now the planet Donda has a mass of 3.56 times 10 to the 3 kilograms, and the moon is orbiting at a period of 3.52 times 10 to the 5 seconds. So as you can see, I've got the centripetal acceleration labeled here towards the planet Donda. Now what we want to do is we want to find the velocity of the moon going around. So to start off, well, some equations we know. We know that what we're going to do is want to do sum of the forces. It's equal to mass times acceleration. And it's going to be centripetal acceleration, since that's the only acceleration happening. And the force we know is going to be the gravitational force. So you can say F equals G, which is the gravitational constant, mass of Donda, mass of the moon, divided by r squared, the distance away from the centers. So that's the force acting. We also know that centripetal acceleration is equal to v squared over r. And the last thing we do know is that for circular motion, velocity is 2 pi r over t, where t is the period. So what we can do is, let's do this sum of the forces here and see what we get. So we get G md mm over r squared. So that's the only force acting is the gravitational force between these two. So that's just this. That's equal to m. What's accelerating? It's the moon that's accelerating towards Donda. So that's the mass we use, mass of the moon, times the centripetal acceleration. Now centripetal acceleration is v squared over r. V squared over r. Now if we look at this, mass of the moon can be divided out from both sides. So we have g, which is a constant, md, which we know. We don't know r, and we're looking for v. So r and v are two unknowns right now, so we can't solve this yet. But we also have another equation, v equals 2 pi r over t. Now this also, we know t, and we don't know v and r. So we have two equations, two unknowns. So all I'm going to do is solve for one and plug into the other. So since I want to try and find what v is, I want to solve for r in one equation and plug into the other equation. So I'm going to do that in this equation, since I already have this up here. So I'll say g md. I'm going to multiply r squared to this side, and v squared I'm going to divide to this side. So we get v squared over here equals multiply over r squared over r, which simplifies down to r. Okay, so r equals gmd over v squared. So I can plug that in here for r. So I get v equals 2 pi r over t. 2 pi r, which is gmd over v squared, divided by t. 2 pi r over t. Okay, so now I got to simplify this a little bit. So we get 2 pi gmd. Okay, t stays on the bottom of this fraction, so it's over t v squared. So now I have v equals this. So I'm going to multiply v squared up here to give me v cubed equals 2 pi gmd over t. So all I have to do is take the cube root of that, and that will give me v equals, now I can start plugging in numbers. So it's going to be 2 pi g, which is 6.67 times 10 to the minus 11, and mass of Donda, which is 3.56 times 10 to the 23rd, and that's divided by t, which is 3.52 times 10 to the 5. And all that is the cube root which gives me a final velocity of 751 meters per second.